Welcome to Data Structures with Professor Califf. Today I'd like to talk about rehashing. In the last video, I mentioned that there are requirements for good hash performance. Specifically, we need a table size that's prime, and the table needs to be less than half full. So then the question becomes, how do we guarantee that the table is less than half full? And the answer is rehashing, which we're going to talk about today. It's essentially growing the hash table. This is going to be similar to growing a dynamic array as you would if you were implementing something like ArrayList in Java or vector in C++. But it's a little bit more complex because we do have this whole hash index involved. So the first question is, when do we rehash? The answer is before the number of items goes over half the table size, because we need to keep the size of the table at least double the number of items. And in general, we want to do it just before inserting that item. So what we want to do is when we're doing an insert and we know that this item is going to push us over half, we go ahead and do the rehash. One of the challenges is getting the new size because that table size does need to be a prime number. We can't just double. What we'll typically do is simply pick the next prime above double the current table size. We don't, however, want to compute these prime numbers on the fly. That's a fairly intense operation, one we don't want to be doing in the middle of our insertion and search operations. What we're typically going to do is to have an array of prime sizes that goes above double the expected maximum number of items. So we'll have a prime number that is where we want our table size to start, and then we'll set up additional prime numbers, making sure that we go up to a value that is more than double the highest number of items that we think we could possibly expect to have. And there are lots of places out in the world where you can find prime numbers and easily get the set of numbers that you want. So then how do we actually do it? When we've got our prime sizes, we know how big to make it, we know when to do it, so what do we do? Well, first of all, we're going to create a new array at the new size. Then we need to go through the old array, and for each item that's in the original hash table, we need to insert that item into the new hash table, the new array. But note that that's typically not going to be at the same location. We have to use our hash function to compute that new location, and of course our collision handling technique to find the actual spot where we're going to put the item. So this works exactly the same way as when we originally inserted the item. We just have a new table size that we're using for the process. Then we're going to delete the old array if we have to manage memory. So if we're using dynamic arrays in a language like C++, we'll have to take care of that. If we're in a language with garbage collection, then we won't have to do that. Then finally, we're going to set up our variables so that we're now using the new array instead of the old one as our hash table. Let's do a quick example. I've got an array of size 11 here. I want to insert 16. My current number of items is 5. So if I insert the 16, I'm going to go over half of the 11. So I need to do my rehash. So the first thing I'm going to do is create a new table of size 23. I picked 23 because 11 times 2 is 22, and the next prime up is 23. So now I'm going to go through the table, and each time I get to an item, I'm going to insert it into the new table. So the first one I get to is 35. The 35 mod 23 is 12, so I'm going to insert the 35 at that spot. Then I insert the 3 in its spot at 3. I insert the 24 in its spot at 1. I insert the 26. It should go at 3. I'm doing linear probing, so I drop that in at 4. Then I have 2 mod 23 is 2. And so at that point, my rehash is complete. I delete the old array. I've now set things up so that my current hash table is this array. And then I can finally insert the 16 into the spot it goes into in the rehashed table. Thanks for watching. I hope that gives you a bit of an idea of what rehashing is all about and how we might do it. Hope to see you next time.